Hi, I'm John Logring, a wildlife ecologist with the University of Minnesota. I will be co-teaching the Fundamentals of Statistics segment of this series. The intent of this segment is to review many of the concepts you might recall from an introductory statistics course or teach you those concepts for the first time. Our goal is to afford you a sound statistical background that will help you interpret the data you are collecting, as well as critically evaluate the reports you might be reviewing. The learning modules will contain a presentation as well as a series with real data, so each student can practice and apply the concepts to real-world example data sets. You will use both Microsoft Excel as well as the free statistical software package R, and we will be right there to get you going as well as answer your questions. The Fundamentals workshop will cover topics related to populations and samples, variation, measures of central tendency like mean, median, mode, data distributions, confidence levels, and hypothesis testing. We'll then apply those concepts to and discuss several statistical tests of association, such as correlation and regression analysis, as well as tests of inference, such as a chi-square test or a t-test or analysis of variance, and perhaps others as time permits. I realize it's a wide swath to cover there in a few hours, and everyone will come to the workshop with a wide variety of preparation and experience. So the introductory unit is going to be flipped. That is to say, I'll prepare a lesson, video, online, that each participant is to watch and view ahead of time. I'll also have some beginning or introductory examples there, so you can become comfortable with the introductory material prior to arriving at the workshop. We can then spend the time on the case studies and the practice applications of those initial concepts.
So why are statistics important to us in our work? Well, in environmental fields, we typically are measuring some sort of natural response or natural condition, whether it's out in the ambient world or whether it's in organisms, and assessing why they're changing or if they're changing, and the ability to assess whether any changes that we see are due to a random variation or due to some actual influential factor is really important. The ability to use and interpret statistical methods and results can enhance our work and lend an underpinning to whatever interpretations we're making. It can also assist in our own data investigation, and it can also help us critically interpret the work of others. Some of the things that I've found that it can help me with in these scientific endeavors are in discerning patterns in data, especially complex data sets.
Hello, I'm Dennis Helsel, instructor for the one-week class Applied Environmental Statistics. Major topics in the class start with 4 basics. First, which parameters and tests fit the characteristics of your data? Should you use a mean or a median to describe the center? How do you know which? Should you transform data to a different scale? How do you deal with outliers? Second, how do you do hypothesis testing in a credible way? How do they work? I've heard they're non-parametric tests, parametric tests, and permutation tests. Which type of test should I use? There's blocking. What does that do for me when I run hypothesis tests? Third, how can I build a good multiple regression equation? I know that there are newer, better methods than just R squared, but what are they and how do they work? Which should I use? Fourth, how can I do trend analysis for my messy environmental data? How do I deal with things like seasonal variation or relationships to outside variables? The focus in this class is not on deriving equations, but understanding what each method does, how it works, why to use it, and sometimes why not to use it. For those of you who think that the class is too basic at the beginning, I promise you, you won't think that by the time that we're done. After each lecture, each student will run an exercise on their computer using our software. Our goal is that when you get back to your desk the next week, what you've learned goes back with you. You can take these methods and apply them directly to your own data. The primary prerequisite for this class is that you know that you need this material. We'll take care of presenting it in a way that you can understand. I hope to see you in the class this coming November.
Hi, I'm Karen Jensen.
Hi, I'm Hong Wang. We are both environmental scientists at the Metropolitan Council Environmental Services.
And we are here today to give you some examples of how we have applied statistics and the open source software package R to assess our large sets of wastewater, river, stream, and lake data. We use R packages like R Commander, R Studio, ggplot2 to analyze river data using scatter plots, box and whisker plots, and box and whisker plots overlaid on flow duration curves. And we recently completed a comprehensive report on 21 streams in the metro area. We used R and statistics to calculate summary stats like means, medians, and confidence intervals. We used R to create incredible box plots that allow rapid visual comparison of water quality in the 21 streams.
And I use a statistical R package called QW-Train to estimate water quality trend in the stream and river for last 20 and 40 years, and link those trends to potential change in watershed land use, wastewater treatment plan, and other management practice. This provides valuable information for TMDL implementations and water resources management decision making. The use of statistics add great value to our studies.
Hong and I and the rest of our team encourage you to attend the statistics course series and learn valuable techniques to make the most of your data. We'll see you there.